Hi everyone, this is Group 7 from Division Q. Our group members are Siddhi Samvai, Sania Bhattar, Sanket Palkar, Anushri Sapate, Ruta Sapate, and Shruti Saswade. We are going to learn about topic Hardwired Control Unit. Hardwired control unit generates the control signals needed for the processor using logic circuits like flip-flops. Control memory is absent in these control units. This control unit uses RISC microprocessor. These type of control unit rely on the instructions to be optimized to produce best results. Also, because of RISC microprocessors, these type of control unit are capable of better parallel processing than microprogrammed unit controller. Now let us learn about designing of hardwired control unit in brief. The decoder and encoder generates the required set of control signals. The step counter is responsible for step-by-step execution of instruction and it resets to 0 when instruction is completed. Detailed block description. The step decoder generates a special clock signal for each step or time slot in the control sequence. The instruction decoder decodes the instruction loaded in IR. The output of the instruction decoder consists of a separate line for each of the M machine instruction. According to the code in the IR, only one line amongst all output lines of decoder is set to 1 and all other lines are set to 0. The input signals in encoder are combined to generate the individual control signals like add, read, etc. The end signal starts a new instruction fetch cycle by resetting the control step counter to its starting value. When run is equals to 1, the counter to be incremented by 1 at the end of every clock cycle. When run is equals to 0, the counter stops counting and this is needed whenever the WMFC signal is activated. Now let us learn more about advantages and disadvantages of hardwired control unit. Its advantages are it is fast because control signals are generated by combinational circuits. The delay in generation of signals depend upon the number of gates. Its disadvantages are the more control signals required by CPU, the more complex the CU will be. No flexibility as the modification of actual hardware would be needed for modification of control signals.
Multiplier CU. The multiplier CU is based on Booth's algorithm. It uses step-by-step instructions from the Booth's algorithm flowchart until the multiplication is complete. Let's take an example, minus 8 into minus 13. Firstly, we will convert these values in binary. Then, we will set accumulator as 0. Now, we will start with Booth's algorithm cycle. So what we do here is we compare the Q0 and LSB, that is least significant bit of Q, and according to that, actions are performed. Since here both values are 0 and 0, we directly perform ARS, that is arithmetic right shift, and then we will move to next cycle as shown in the flowchart. Now multiplication is performed in many cycles. First step is to check the value of Q and Q0 to decide whether A plus M or A minus M is to be performed. The value of minus M is drawn on 2's complement circuit and adder circuit will add A with M or A with minus M. After the addition is done, arithmetic right shift will be performed by multiplier control unit. The value of cycle will be reduced by 1. Once the value of n reaches 0, final answer will be stored in accumulator and multiplier register combinedly. Thus, this is how we perform Booth's algorithm in hardwired circuit.